Okay, so we talked about arithmetic sequences, and now we're going to talk about arithmetic series. And of course, what that means is that we take an arithmetic sequence, which we talked about in detail, and then we add the terms. So this was the formula we talked about to calculate any term in an arithmetic sequence. You have to know what the first term is and the common difference d, but this is what we just talked about in the last video that I had. So believe it or not, like, I think this is kind of interesting. I mean, I'm a nerd, but this is kind of interesting. So when we sum up each term from this sequence, there's actually a very handy formula for that sum. So summing up this sequence can come down to two separate formulas. The first one for this sum, notice I don't even need the sum notation for it. Like the whole sum, if you know how many terms you're trying to sum up, is going to be n over 2 times a sub 1 plus a sub n. Or you could use this formula, n over 2 times 2a sub 1 plus n minus 1 times d. Now, when do you use each formula? This formula you will use if you know the first and last term of your sequence, and you use the other formula when you don't know the first or last term. So this is kind of interesting. So let's just take a look at how to use this. Okay, so I want to consider this sequence here. -7, -3, 1, 5, and notice this is an infinite sequence because we've got the dot, dot, dot. I want to evaluate s sub 10, which means that I want to evaluate summing up the first 10 terms of this sequence. Now, instead of taking the time to figure out what are all 10 terms of this sequence, I can instead just use a formula. So notice I don't know the last term of this sequence. So since I don't know the last term, it's an infinite sequence, I instead just want to sum the first 10 terms. So this is the formula that I'm going to want to use. So I'll just write that down. So that's what we're trying to plug into. And what is the common difference? Well, the common difference can be found, I just need to take one term minus the previous term. So if I just take, let's just do 5 minus 1. The common difference here is 4. Okay, so now I have really everything I need to figure this out. I'm trying to do this for s sub 10. So using this formula, I'm going to take 10 over 2, right, because I'm replacing n with 10. So anywhere I see an n, I'm going to replace it with 10. The first term was given to us. That was -7. Plug in n again, and then remember the common difference was 4. So there's everything that I need. And so now I just calculate this, and I get that this sum will come out to 110. So notice how much easier this is than if I had just tried to sum up these terms by myself. Then I would take -7 plus -3 plus 1 plus 5 plus, and now I've got to keep calculating terms because I've only got 4 terms. So then I'd have to go plus 9 plus 13 plus 17. So let's see, how many is that? 1, 2, 3, 4, 5, 6, 7. We're still not done. So you'd have to keep going. And this is just a longer process to figure out versus having this formula here. This has already summed up the 10 terms for me. So boom, I don't have to keep going with this. I can just trust this. So that's the idea with these formulas. Okay, so now here's a challenge for you. I want you to evaluate the first 50 positive integers. Okay, so this is something we want to pay attention to. Positive. This is kind of changing how we're viewing our sequence. Now, I want to treat the 1 as the first term in the sequence. The common difference is still 4, right? That didn't change. But that changes now how we want to view this. This is the new a sub 1. So with that in mind, why don't you try to find the sum of the first 50 positive integers and hit play when you're ready. Okay, so once again, so I want to use that formula, so I'll just write it out. So that was n over 2 times 2a sub 1 plus n minus 1 times d. So this is everything that I need to plug in. So now I want to find the first 50 integers using a new a sub 1. So I'm going to plug in 1 as my a sub 1. And here's everything that I would have had to plug in. Oops, I'm sorry, my n should be 50. So if I evaluate this, this comes out to 4,950. And I will say, you definitely, like, if I just asked you to add up 50 integers and then you have to go through and figure them all out, you would be probably a little irritated with me. So having these formulas is very handy and sometimes essential, because otherwise you're never going to get a problem like this done. All right, so for our next problem, we have the sum of the first 15 terms of an arithmetic sequence is 345. If the 15th term equals 65, find a sub 1 and d. Okay, so this one's interesting because we're told we know the sum of these 15 terms, but we're also told what the last term is. And so because of that, since we know the last term, we can actually use this formula here. So that's going to make our lives a little bit easier. So I'm going to have s sub n equals n over 2 times a sub 1 plus a sub n. All right, so let's plug in what information I know in this formula. I know that this sum equals 345 when n equals 15. So here's all the information I have, and I also know that the 15th term is 65. So notice how, because this is the 15th term, like a sub 15 I know is 65. I plugged in 15 for n, and s sub 15 is 345. So I've kind of like leveraged the knowledge or what I know in this problem. And this equation here, so the good news is that I can solve this. So let's see. I'm going to go ahead and multiply both sides by 2 over 15. So let's see. 345 times 2 over 15 is 46, so that gets rid of the fraction entirely. So now I've got 46 equals a sub 1 plus 65, and then I can subtract off the 65, so that negative 19. So now I've figured out my a sub 1, so that's cool. So next I have to figure out what is the common difference. So let's clear some space. So we just found that the a sub 1 is negative 19. So we have the other formula with sequences. So remember that formula was a sub n equals a sub 1 plus n minus 1 times d. So if I know this a sub 15, now I can leverage my sequence formula to figure out d. So if the 15th term equals 65, that's found by taking negative 19 plus 15 minus 1 times whatever that common difference is. And now you can see how this is just another algebraic formula. So let's see, if I go ahead and add 65 plus 19, I get that that's 84. And then if I divide 84 by 14, I get that d equals 6. And now I've figured everything out from this. Okay, so the last thing that I want to do is I just want to evaluate a few sums with you. So let's start with this first sequence. So the thing that tells you that it's arithmetic is that, well, we're adding like a constant to this. But you want to play around with this sequence a little bit and the series before you start trying to bust out a formula. You like want to double check that it's arithmetic. So let's take this inside for a second. Let's treat this as an a sub n. So forget about series for a moment. Let's just go back to thinking about sequences. What would the first term of this sequence be? Well, I would find that by plugging 1 into the sequence. So I get that the first term is negative 1. Let's just calculate a few other terms just so that we feel comfortable with this. So let's see. The next term would be negative 3 minus 5 times 2. So let's see, that's negative 13. What about the next term? I have negative 3 minus 5 times 3, so that's going to give me negative 18. Okay, so I can see now that here's my a sub 1. The common difference between these terms is actually negative 5, right? So let's do maybe one more just to convince ourselves. So negative 3 minus 5 times 4, this equals negative 23. So the common difference between these terms is negative 5. So my a sub 1 equals negative 8, and the difference is negative 5. So sometimes you want to play around with the sequence a little bit just to convince yourself that you are dealing with an arithmetic sequence. It's not always obvious how it's arithmetic, so calculating a few terms can help. And then notice that the last term, we want to get to this 19th last term. So we can actually calculate that now. Knowing this information here, I can figure out what the last term is. So the 19th term will be calculated by taking a sub 1 plus 19 minus 1 times negative 5. So if I just run that out, I get that that will be negative 98. So I'm going to note that over here. A sub 19 equals negative 98. And now I've got all the information I need to actually just calculate this versus having to use those big long formulas. It's debatable whether or not you've saved time with this. It's just another way you can kind of go about this. So let me clear some space. And now we can use the sum formula. So the sum will be, so actually I'll just write the general formula for a moment. This is n over 2 times a sub 1 plus a sub n. So if I want to get to the sum of the 19 terms, I can take 19 divided by 2 and then negative 8 plus negative 98. So that's the whole calculation that I can do. And this equals negative 1007. So that's summing up all 19 of these terms. Again, if you think about how we talked about this before of like splitting up the sum and then using like sum formulas, it's debatable as to whether, what's the easiest. So I've got one more here. So I want to challenge you to do this one. I want to point out that we start at k equals 4 and we go up to 15. So you can still think of this as an arithmetic sum. You're going to have to play around with it a little bit, but you're going to have to just kind of change like how many terms are we actually looking for. So play around with it for a moment. Just think about like how to reframe the language of this. And then you can try to finish the sum. So give it a try and then hit play when you're ready. So the first thing I want to do, I want to treat this as a sequence. So the first term in this sequence, starting with k equals 4, is going to be 2 plus 4 times 4. So I'm trying to reframe how I think about this sequence by saying this is the first term in my sequence. So this is how I'm going to set it. So this is going to be just 2 plus 16, so that equals 18. Okay, so there's the first term. So let's keep going. So 2 plus 4 times 5. So if I do that, that's going to be 22. And then a sub 3, so let's see, that's going to be 2 plus 4 times 6. So that's going to be 26. Okay, now I want to just clear something up in case this is throwing you off. So I'm using the indexing from here. So this says I have to start at 4. So I started this at 4, but I want to treat this as the first term in this sequence. So I'm using this as to what to put in the brackets here, and then I just increase it by 1. And then I set those to be how I'm thinking about my sequence. Do you see how I did that? You can always post a comment if you're not sure. Now, what's the common difference? The common difference I can tell is 4. So I want to treat this as a sequence where the first term is 18 and the common difference is 4. And so I want to get to what happens when I plug in 15 for this. Here's where this can kind of mess with your head. How many terms, if I'm starting at 4, like how many terms am I actually summing up here? This is 15 minus 4. The last term will actually be the 12th term in this sequence. How did I get 12, you're asking? So we're starting at the 4th term, right? So that term is included. So you can think of this as 15 minus 4. That would give you 11, but that starts at all the terms after 4. We're also including the 4th term. So we have 12 terms in total in this sequence. If you're not sure, like if you're having trouble kind of wrapping your head around how I got the math on that, you can just like, it's rudimentary, but like take your fingers. 4, 5, 6, 7. So if you just count all the way to 15. So if you're including the fourth term, so when k equals 4, which we are, if you count out how many terms this is in total 12 terms. I know sometimes it kind of messes with people's heads because you want to take 15 minus 4, but in doing that you end up excluding the fourth term. So we want to make sure that we're just including all of those. Okay, so that being said, when I calculate the last term in this sequence, so what am I plugging in for k? So it's coming from the sum, so we stop at k equals 15. So that's the last term in this sequence that I'm setting up, so I can figure out the last term. So this ends up being 62. And so now I know all the terms in this sequence, so I'm good to go. Okay, so let me clear some space. And now I know the first and last term in this sequence. So this sum of all 12 terms is going to be found by taking 12 over 2 times 18 plus 62. So that's what I have to do. So if I run that calculation out, the terms all added up together will equal 480. So that was definitely kind of a tricky one just because the index got kind of messed up. So this is a good way to kind of get you to see the difference between sequences and series and to kind of play around with it a little bit. Okay, so that brings us to the end of this video, and so I will catch you guys in the next one.